So it says the graph of the output of the EMF versus time for an AC generator is shown below. So you can see here that we've got a nice alternating current and we've got an EMF there which says 39.45. I'll just write out 39.45 volts. It says define the term root mean square value of an AC voltage, and you guys have to go and study this. Please go find your exam guidelines and then go study this. But basically, your root mean square value is the average voltage. It's the actual voltage that you get out, because remember that these peaks get cut off. So it's the average voltage that is supplied to the circuit. Now it says calculate the root mean square voltage of the generator. Well, if you go look on your equations sheet, you will see that there's an equation that says V root mean square is equal to V max over root 2. And you can see that here we've got the value of 39.45. So we're going to go 39.45 divided by root 2. So we're going to pop that in our calculator, and we're going to see it's 39.45 divided by square root 2 equals 27.895. So we round it up and it becomes 28. So that is equal to 28 volts. So that is the root mean square. Now it says give one reason why AC voltage is preferred to DC voltage for everyday use. And that's always the same reason, guys. It's because it's to prevent from loss of voltage or loss of power due to attenuation when your voltage is transported across long distances. Okay, now I'll explain what I've said there. Okay, do you understand that you have got Coburg, for example, which is producing lots of electricity, and what it does, it steps up, okay, the voltage. It steps it up to a very high voltage, but it is AC, okay? Then what happens is it travels very long distances, and then it gets to another transformer box, and they step it down, and then they get another transformer box, and they step it down, and eventually it gets to your house where it is at 220 volts. Well, actually 3 something, but don't worry about that. Okay, we get out to 20. It's actually sitting at 315 volts, but that's the peak voltage, and this is the root mean square. Okay, now what happens is the reason they put this in very high voltage is because this reduces the loss of electricity due to friction. Okay, it is better to have a low current high voltage than to have a high current low voltage, because current is the rate at which the electrons are going past, and the faster they go, the more the friction and the more the heat due to that. Okay, so we want to have low current high voltage, so there's lots of high voltage. Obviously, if we can't have this 100,000 volts being put through our house, we would fry. Our toasters would fry, microwaves would fry, everything would fry. So we need to step it down, and the only way we can step it up and step it down, the only way these transformers work is if we have alternating current. Transformers do not work with direct current. It has to be alternating current, and that is the one very important reason why we use AC voltage. So we can step it up and step it down, so we can transfer our electricity over long distances without reducing the loss of electricity. Okay.